Today we're looking at determinants and inverses of matrices. The main thing we're looking at these are because we're going to use these to problem solve other scenarios in matrices. So the first thing we're going to look at is the determinant. Now the determinant is when we have a square matrix. So that means it has to be the same rows and columns. Now sometimes they may refer to it as finding the det, so DETA, or sometimes you might see these straight lines. You'd only see those straight lines maybe in trial exams. That won't be what VCAR will use, but just in case like that terminology is used in some of your trial exams. All right, so we're going to manually find the determinant of a matrix and only if you look there, a 2 by 2. So we only have to manually know how to work out a 2 by 2 determinant. The rest we would do on a calculator. So if you have a look there, we'd have this 2 by 2 and we would have 4 elements in that matrix. Now, the rule to find the determinant of that matrix is you times the number in the A position by the number in the D position. Then you subtract the B by the C. So they've got an example there. So if you look here, we can see A is 2. And then we times it by D, which in this case, so you can see A was 2, D is 5. So we've times it by 5. Then we're going to subtract the B spot, which, B is 3. So you've got 3 times 3. All right. So you can see that would be 10 minus 9, so that's where they've worked out the det of A is equal to 1. All right, so if we do this one, the determinant of H down here as an example, we would do A times D, so that'd be 2 times 3, that's position, minus 4 times 2. So that would be 6 minus 8, so negative 2. So note the determinant can be a negative number. That's okay. All right, so here's an exam question up here, and it's pretty easy, and you can see because it's question 1. So which of the following matrices has a determinant of 0? So you're just going to go through them. This one would be 0 times 0 minus 1 times 1, so that would be negative 1. So it's not that one. This one would be 1 times 1 minus 0 times 0. That'll equal 1. It's not that one. This one would be 1 times 6 minus 2 times negative 3. So that, be careful, a negative minus a negative becomes a plus. So that one would be 12. This one would be 3 times 4 minus 6 times 2. So that would be 12 minus 12, which is 0. So I'm happy to take that one as the answer. Pretty simple, pretty straightforward. Alright, so now we're looking at the inverse, and we actually needed to know how to do the determinant because it's part of working out the inverse. Now I'm just going to help you out with some understanding what the inverse is because it'll help you problem solve. So if you have an inverse of something, say the 3, if you want the inverse of 3, it's actually like raising 3 to the power of negative 1. So if you had 3 to the power of negative 1, what you actually have is 1/3. If you have something to the power of negative 1, it's like saying 1 over whatever you've got. So if you have a look, if you were timesing something by 1/3, essentially that's the same as dividing by 3. Would you not agree? Isn't it true? If you times something by 1/3, it's like dividing by 3, isn't it? Yeah? So when you've got here, when you times something by a matrix inverse, it's like dividing by that matrix. So it's like dividing by matrix A. because the inverse would actually mean like 1 over A. So if you times by the inverse, it's like dividing by that matrix. All right, this will help you, and later on you'll see in a little bit. All right, so let's go work out how to find the inverse. In your calculator, you simply just type in your matrix and you raise it to the power of -1. But once again, we need to know how to manually work out the inverse of a 2 by 2. Okay, they will find ways to test that you know how to manually do it. All right, so you can look here. We've got these letters in those positions again. So we've got A, B, C, and D. Okay, so what you'll notice with the inverse is that we change the D and the A's position. See how they've diagonally gone different? B has stayed the same spot, but as you can see has become negative. So if it was already negative, what will it become? Positive, good. And you can see that's the same case with the C. So the C stayed there, but it's become negative. All right, so that's how it changes. Now also out the front of it, out the front here, is you are also timesing it by, you're going to pre-multiply by 1 over the determinant, because you can see that rule AD minus BC is the same as saying the determinant. All right, so this is how you'll manually do it. So just down here though, they're talking about if the determinant, like you can find the inverse. Sorry, I'll just say this. So you can find the inverse as long as the determinant of the matrix, does not equal 0. Does not equal 0. And what that means is if you typed in your calculator, if you tried to do 1 over 0, you'll get an error. You can't do that. You can't have a 0 on the bottom of a fraction. So that means if we get a 0 for the determinant, that means you cannot find the inverse. So up here, we're writing that statement. If det equals 0, the inverse is not defined. So you might want to write above that, cannot find inverse. That means cannot find inverse. Okay, and the other thing is they like to say that it is singular. They'll call matrix A is singular, or you might see the other word, no unique solution. So if the det equals 0, the matrix is known as singular, and we say there's no unique solution. Okay, so just looking at this next little point here, they said if you multiply a matrix, so what that means, if you take matrix A and you multiply it by the inverse of matrix, what you end up is the identity matrix. So you'd end up with, say, 1 0, 1 1 0 0, remember? Like that. So that makes sense. So remember, if you think about normal, if you times 3 by its inverse, you end up with 1, yeah? So if that's pretty much normal. So, and it just says use your calculator to find any inverse or determinant that is bigger than a 2 by 2. You can still work them out on your calculator if you need to. Now, just take note that on your calculator, you can either type in the little letters, we'll type it in, DET, put a curly bracket, and then put your matrix, and then press enter. That will give you the determinant. And if you want the inverse, you simply type in the matrix, whatever it is, and raise it to the power of -1. That's how you find them on your calculator. All right, let's do this example here. They're showing you how the inverse was found, but let's have a look. Let's do it ourselves. So we can see this is the determinant where we've done A times D minus B times C. So we know the determinant is negative 2. So we go 1 over negative 2. Then we swap these two round. So we have 3 and 2. And I make the other ones negative. Okay. So when you have, remember, you've got to remember when you have a scalar multiplication, you just times everything inside the matrix by that. So what that would be 3 over negative 2, negative 4 over negative 2, negative 2 over negative 2, and 2 over negative 2. Now we can simplify those, and that would be, because 3 over 2 is the same as negative 1.5, so they've done that. Negative by a negative becomes a positive, so that's 2, 1, and this one should be negative 1. In this example, I believe they've forgotten the negative there. So there you go. So that's how I could find the inverse manually. This next bit, it's just a little bit of explaining what is happening when the determinant equals 0. So because I said we're going to use the determinant and the inverse to find, solve problems, more thing. And what we're going to see, if we have two equations, say normally, so if x and y, if we have two equations graphed like this, and when they cross, what we say when we solve and we find that, that's like solving them simultaneously. And that point there is the unique solution. Oops. So that's what's happening when you have a unique solution. You're finding that one spot where these two graphs equal the same thing. All right, so that's what they mean. So when we have the determinant when the determinant equals 0, we know there's no unique solution. And these are the scenarios that could be happening. So we could have two lines or equations that are parallel. So they will never cross. So there's never that unique, they'll never cross, there'll never be that unique solution. Or the other scenario that it could be is down here where it's actually the same line. Even though the formula looks like this is still the same equation because everything's been times. You don't need to stress too much about this, but this would help. It's probably a good key to know if we're aiming for a 50. So not stressing too much about this. It could possibly come out, but that's what's happening if you have a determinant equals 0. These are the two scenarios. So here's a couple of examples. Now, I know it says simultaneous equations, and we haven't quite gone over that, but we don't need to, we'll go over that in a minute. When you're solving them with matrices, you end up setting up a matrix like this. So these get set up in matrix. And the way you can say whether these can be solved, these two equations, is by determining if it has a unique solution. So it will have a unique solution if the determinant is anything but 0, yeah? Because if it's 0, there's no anything but 0. Because remember, if det equals 0, there's no unique solution. So if there is going to be a unique solution, the determinant will be something other than that. So if we go down here, let's do those determinants. You can see I'm going 2 times 1 minus negative 1 times 1. So remember, that's going to become a plus, so that one ends up being 3. I don't know what they did there. They stuffed that one up too. Anyway, let's go down here. This one's determinant is 4 times 1 minus 0 times 2. So that one equals 4. So does this one, because the det equals 3, it has a unique solution. So that one it does. So that one, yes. This one, yes. And let's do this last one. This would be 1 times 4 minus negative 2 times negative 2, which becomes a positive anyway. So I end up with 4 minus 4, and that equals 0. So that one, this one, no unique solution. So something's happening, these two equations are either running parallel or are the same line, which I think they are running parallel. So when it says how many have a unique solution, just 2 of them. All right. Now, this is why we are learning to work out the inverse, because if you remember what I said, I said that the inverse is a way of dividing in matrices. A way of dividing in matrices. And that's handy to know because it'll help you solve problems. So what we're going to look down here is every time you see this X matrix, we're going to pretend that's the one that we don't know. It would be like an equation. This is the one we don't know, and they're asking us to solve for it. So say they're asking us to solve for X. Okay, matrix X. So you can see over here, this is how we would get the solution. This is how we would find it. Now, if you were adding a matrix to X and it equals B, the way you can see, you would move that A on the other side and you can see it becomes a subtraction. Is that not the same way we would solve an equation? Yeah? If I had X plus 3 equals 5, actually, sorry, I'll change it to look like what you do. If I had, 5 plus X equals 8, you'd move this 5 over and it would be 8 minus 5. Isn't that how you'd work out what X is? Yeah. So that's what we've done here. So if you look at this next one, we've got X minus A equals B. So if I move it over, you can see it's become plus, and that's how I've solved it. Now when we go down here to this one, this is like a scalar. So if I'm timesing something by 3 and it equals, if I move it over, I will divide. So this one, when we're trying to find matrix X, we will times it by 1 over whatever we were multiplying it by. Okay, so that's fine. Now when we look down to this one here, what we're looking at is we're multiplying here. These two are multiplying. Now if I wrote out a simple equation like this, if you were solving it, you'd move that 2 over and X, you would be dividing by 2. That's like saying, it's like timesing by a half. Dividing by 2 is like timesing by half. So can you see, if I was trying to work out that matrix, if I've got matrix A times X equals B, what I really want to do, because I want X by itself, I'll bring the A over. The opposite to multiplying is dividing. But we can't really divide in matrices. What we do is we use the inverse. We times by the inverse. So what we're going to see is that's the same as saying the inverse times by B. So that's what I mean. It can help you solve it. If you come up to a problem and you go, I've got that one and I've got that one, they've told you the scenario and they want you to find X, well, simply I would have to move A over. If I move A over, it has to divide, but we don't divide, we times by the inverse, and that's what's there. Now, you have to be really super careful about order. So be careful with the order here, because you can see when the one is pre, so can you see that it's in front? It's in front when you times it over here. When the A was after, the one that you knew was after the unknown, you have to times after. So order's really important. So this is when you are post multiplying, because it's post here. And this one is, the A is pre, so you're pre-multiplying here. Okay? So just be careful. If you know this, you'll be able to solve all problems. If you think about it in practical application, when they're giving you a few things, if you write out a little equation, work out what you would do to solve it. If it was just a normal equation, and then go about it, you'll find you'll have the answer.